Electro-Anarchy.
Today I thought I'd check some of these lithium cells that I've collected over the years, and just in all different kinds of things, like these cell phones. These came in from older flip phones. Same way with these Motorola's. Had a lot over time, and anyway, I want to see if maybe they can be used for other projects here. I've got these, like this one here. This is a 3000 milliamp hour, 3.7 volts. This one's also a 3000 milliamp hour, 3.7 volts. So if these two could be used together, then it's a good possibility, maybe I can get, because I'm sure this probably won't go its rated capacity, but at least, get quite a bit more use out of these guys in something like the Picade project here. Now the thing I want to know is if this circuit board in here, if these do indeed contain the undercharge protection, because overcharge I've got that covered. It's the undercharge that I'm worried about. So let's see what we got as far as voltage on these guys. Let's see if they're dead or if they're alive. Alright, first off, let's see what we got on these guys. We've got, yeah, that looks good. 3.45 volts. You guys see that? Yeah, you see that. Okay. And this one here, let's see. Let's see what this one is. Actually, I think this one over here I've actually charged before, so I think I know that one's good. And this one looks good too, 3.47. So these two together should work. Yeah. Alright, let's see what we got on these guys here. Alright, so we got marked negative and positive here. Now these have been sitting idle for, I know, a couple years. Wow. That one's got life. Let's see about this one. Positive, negative. Positive, negative. Okay, I'd say that one. This one's dead. This one's totally dead. Now I don't know if I can kickstart it or not. I can always try here. Let's see if this one will kickstart. Let's see what we got here. See if I can bump a charge in it. Alrighty. Negative and positive. Make sure I don't goof that up. Alright. 2.61. 2.67. It seems to be taking a charge. 3.73. Alright, let's see if that did anything. Alright. Positive, negative. Positive, negative. Yep. Bumped it. Got it working. Alright, so this one's good. Let's see about this one. Positive and negative. Let's see what we got here. That's live. Now this one, these are actually marked. So this one's a 1000 milliamp hour, which isn't too great, but if you're going to make some sort of small robotics project or something, I mean, you think about, this is 3000, and you look at the size and you think, okay, 1000 here, you got 1, 2, 3, 4. So really and truly, this should be, as far as, size and package size and power per package, this should be 4000. Just by the overall size here, but it's not. So I mean, for what we're going to build on the Picade, size really isn't that big of a problem, but building some RC cars or something to where, let's say you didn't want to use LiPo batteries, you're just building something just for the fun of it. Well, reusing these old cell phone batteries isn't that bad of an idea when you consider the power versus size. Now, will it live up to the 1000 milliamp hours? I don't know. Depends on how much degradation there has gone on between you know, the lithium and the electrolyte. So just you have to see on that one. Okay, let's try this one here. Also 1,000 milliamp hours. I think these are all identical. Alright, let's see if this one's got a charge. And this one here. Let's see what we got here. We've got a charge. Okay, so all the batteries are good. How about that? Alright, well, let's see now. One thing I want to do is I want to test to see if these things will run down, shut off, protect themselves, and take a charge. So let's see what we can do for that. Okay, I think I found something here that'll work. This is basically a motor out of an Xbox 360 controller. It's one of the rumble motors with the little rumble piece taken off. So it should run at 5 volts. So 3.7 volts should be fine, and it'll put a pretty good load on this battery. So let's see if we can get this thing to run down. See how long it takes to kill this battery. Might take a while. Let's see what the draw on this thing is. Just 2 milliamps. Okay, we're running about 50, 57 milliamps, 58 milliamps. This motor's fairly efficient. Might take a while. Okay, I've hooked up a different meter here just to see when the voltage goes down to 0. This is not exactly for this. This is for higher voltages, but it'll do its thing. So let's see what happens here. Well, as you can see, I got kind of bored waiting around for this thing to die, so I'm going to try to give it a little bit more help. By putting a little interference on it, able to get the milliamps up close to 100. I'm hoping, you know, that would kill it a lot quicker. I guess we'll see. I know I don't have the right equipment for this, but you know, hey, you gotta do what you gotta do. By the way, while that's going on, lithium cells, you can get them almost anywhere. I mean, this came out of out of a tablet, and if you've got a daughter like mine, she's always going through stuff and breaking screens and different things like that. Well, these little $100 tablets, kids play with them for a little while, they break the screens. Don't throw them in the trash. I mean, you could pull these really good lithium cells. I mean, this is an Asus. It's 4,270 milliamp hours. I mean, that's pretty decent. 16 watt hours, 3.75 volts. So, I mean, this is a pretty decent little cell. This one is actually not quite as strong as these two put together, but I mean, it's getting there. Same way with a lot of these other ones. I dug up some of the other ones out of my stash. This one here, this is Highway, which is a really cheap, Chinese phone manufacturer, tablets and whatnot. You know, the that you'll see like around Christmas time, the $30 tablets. Well, it's these guys right here. But I mean, this one right here is 4.2 volts. No, it charges at 4.2 volts, but it's a 4100 milliamp hour, 3.7 volts. I mean, still, I mean, it's lithium batteries. The only difference in the lithiums is the type of electrolyte that they use. Some electrolyte will cause the lithium layer to oxidize quicker. Some, have a longer life expectancy. Some have a shorter one. So remember, on these cheap Chinese ones, more than likely they probably have crappier electrolytes than, say, like these, the Asus, which, they're a name brand. They want to make sure their name is good. But even saying that, you never know. Some of these other... Now, these are stuck together good, but some of these other, cheap knockoff, who knows who made these, those, whatever, but see, this one is about the same as these other two, so if I need another one, well, I've got more. The other thing, too, that's a good place to find these lithium cells is the batteries for e-cigarettes. I mean, these came out of the little, some of the stuff that I didn't use anymore. But you can get these out of e-cigarettes. Some of these are smaller, some are larger. These are 13 millimeter by 450 millimeter, 2.41 watt hours, which is not as good as some of the others. But I mean, for something small, if you got just a small little project, say like some lights, or you want to run a remote sensor, maybe a little small sensor pad or something like that. These things right here, I mean, people throw these things away and they don't realize that, well, there's some good stuff in there. Even if it's just, you use it for a project, or, whatever the case. You're going to have a quadcopter, you don't want to put good stuff in there because maybe it's a cheap 3D printed one and you don't care if you lose it or not. Well, this is the best stuff for it right here. And of course, laptop batteries. The only problem with these versus some of the others, these do not have any kind of protection systems on them when you pull the cells out. So you have to make sure that you use some sort of a protection, an under voltage and an overcharge protection on these. And then some of these come in nice little, they're pinned up with two. So, it's kind of neat. These are in parallel, but you can take two parallels, run them in series, and you can double the voltage and double your amp hours. So, that's kind of cool. I mean, don't just throw stuff away, because some of the stuff's good. Especially if you're cheap like me and you want to do stuff, but you don't want to spend a ton of money. You just want to keep playing with things on the cheap. Now, this battery's been going for a while now. I would guesstimate probably we're running about 20 minutes now. Probably about 10 minutes on the higher load. And it doesn't seem to be indicating any signs or showing any signs of slowing down. The battery is not warming up one bit. It still seems to be good. But every now and then it seems to surge like this. To test these things properly, you need to get basically it's a battery tester charger thing. And what I have over here is just, I mean, this thing is, well, rudimentary and basic at best. I mean, it's really cool. It's really neat for just, quickly grabbing a cell, charging it up, and, seeing if the cell is actually alive and if it'll come back around. One thing to remember about these cells, if you get a cell and you get nothing out of it, and you can't bump it to see, to put some charge in it and see if it'll hold a charge. If you bump it, there's nothing. Odds are these little boards inside of here have an EEPROM in them, and these EEPROMs will only allow you to charge and discharge a certain amount of cycles. Once you reach that amount of cycles, there is nothing you can do. Even if you try to change out the EEPROM, there's just nothing you can do. So your only option at that point is to take this board out, be very, very careful, take this board out, take this Captain tape off, and desolder the board here, and then you can access the cells directly. Then when you access the cells directly, like these guys over here, you're going to have to add some sort of a discharge protection as well as charge protection on these cells. Because trust me, you short one of these cells out, or you overcharge them, or you do something nefarious to these things, they are bad. Very, very bad. They will burn through wood, they'll catch your house on fire, they'll burn your skin, jump flash in your eyes. I mean, these are bad. So you have to be super, super careful when you start opening these up beyond the normal packaging. And if you do take off the control boards, just remember, it's now on you to correctly control these things. Well, after about 2.5 hours and different methods, I finally got this thing to go to 0. And it shut off just like any battery would, any lithium battery would, with circuit protection. So this does have under voltage protection built into the batteries, which is awesome. Did not get hot. Tried first with the motor, ran that for a while, and that got old. Put in a light bulb, increased the amp draw to right at 200 milliamps, and ran it like that. Completely discharged the battery. As you can see, 0, nothing. So let's check voltage and see what we have for voltage here. See if anything spits out any voltage. Should not show anything. Nothing. So, no volts. Good. That's perfect. So, you know, these little batteries, if you're going to be doing some projects or something like what we're going to be doing here on the videos, these are pretty cool. I mean, you know, like I said, if you have a daughter like mine, or if you are just, you know, whatever the case may be, you get these old tablets, you know, take them apart. Look at the batteries that are inside of them. They're pretty awesome batteries. You know, this one here, I haven't torn it out yet, but this one, wow, this is a 15.5 watt hour, 3.8 volts. So this is a pretty decent size battery pack here. I might be taking this out before too long and seeing what I might be able to do with that. And this one over here, this is one, this is another Asus. This one, see what we got here. 3.7 volt, 18.43 watt hours. You know, good batteries, projects. It's awesome. Well, thought I'd share this little experiment with you and everything. And well, off to something else. See you next time.